Good day everyone. Our topic for today is about database concepts. So this will be the intended learning outcomes. So at the end of this video presentation, the student is expected to describe the nature of data, understand the purpose and functions of relational database, describe database elements, understand database relationships, understand how to read a database schema, and describe the uses of databases on the web. So, what is data? It is made up of small facts and information without context. If you give data context, then you have information. Data are pieces of information, and data can be measured, collected, analyzed, and reported. Data can exist in many forms, as a phone number, scribbled on a scrap of paper, as a course listing in a catalog, or a list of test scores on a grade report. Data is distinct from the container in which it is stored. Data can be stored on a flash drive, or in a book, or in remote storage location on Google Drive, Dropbox, or OneDrive. Data can also be stored in a spreadsheet or a database, but these containers are not data. Their contents are data. What is database? Although many people become uncomfortable at the thought of working with a database, a database is really nothing more than an organized collection of information. The basic functions of a database is to store data. If the database is well organized, retrieving the data you want is easy, and you can then generate reports or lists and analyze the data in ways that are meaningful. Database, it is an organized collection of related information. It is an organized collection because in a database, all data is described and associated with other data. All information in a database should be related as well. Separate databases should be created to manage unrelated information. Spreadsheet databases. You can create simple databases in Excel. So a database in Excel is a single table that cannot include any blank rows or columns. This type of database is sufficient for storing relatively small amounts of simple data. But even though you can perform complex calculation on the data in an Excel table, a single table cannot represent or handle complex data relationship. Excel is a great spreadsheet application, but it's not really a database at all. Excel, however, is an excellent complement to any database since it can turn row after row of data into attractive and comprehensive reports and charts. Relational Database Management System. It is a type of database. It uses a structure that allows us to identify and access data in relation to another piece of data in the database. Often, data in a relational database is organized into tables. A database application, on the other hand, is designed to handle complex relationships between various items of data and is correctly referred to as a Relational Database Management System or RDBMS. Many relational database applications are available on the market like Oracle, SQL Server, MySQL, PostgreSQL, Sybase, IBM DB2, and Microsoft Access are just a few. These programs offer various features and interfaces, but all of them access stored data in a standard manner through structured query language. Structured query language is the standard language used to create and work with databases. No? So once a database has been created, SQL is also used to retrieve and manipulate the data. Any interaction among a user program and database takes place through the use of SQL. Even though various RDBMS applications provide their own user interface, SQL is used often behind the scene to create and manage both the database elements themselves and their data. Connectivity standards and APIs. Generally speaking, a database is not portable from one RDBMS to another, but different RDBMS can infer or interoperate using one of the following applications programming interface standards. So we have Open Database Connectivity or ODBC, a standard programming interface for accessing a number of different databases, including Access, DB2, SQL Server, and MySQL. Another, of course, is the Java Database Connectivity or the JDBC, a standard programming interface for accessing Oracle databases which run on the Java platform. An application programming interface, of course, is a set of programming building blocks that specify how software components should interact. Again, so application programming interface, it is a set of programming building blocks that specify how software components should interact. These are APIs for operating system, applications, and website. These interfaces make it possible to connect databases to web pages. Web designers can then use server-side programming languages to build web pages on the fly based on current database content, and you will learn more about this later on. Multiple related tables. Unlike spreadsheet databases, which store all the information in a single table, relational databases store data in multiple tables which are related to one another. So let's consider a database that tracks activities for a gardening supply company. And there might be a table that contains customer information, a table that contains order information, or a table that contains detailed information for each order, and a table that contains product information. Because the data stored in each table is related to the data in the other tables of the database, a complete set of information can be retrieved. So for example, you could retrieve the complete information for a particular order as what we have here in our figure. So this complete set of information is extracted from the customers, orders, order items, and inventory system table as shown as what we have here. Database tables. In a database, data is stored in tables. So the data in a table is organized into a series of rows and columns. And as what we have here, the given figure shows a portion of a typical access database table containing product information or items sold by a garden supply shop. In a database, actually, each row in the table can be referred to as a row or a record. In the table shown in the preceding figure, each record contains information about a different product sold by a garden supply shop. Each column in a table can be referred to as a column, a field, or an attribute. Each field contains a different type of information such as item number, description, unit price, and so on for each product. Database tables is a table data structure that organizes information into rows and columns. It can be used to both store and display data in a structured format. So for example, databases store data in tables so that information can be quickly accessed from specific rows. Table metadata. In a spreadsheet, you can create a table simply by opening a blank workbook and typing. In fact, you can enter any type of text or value into any cell at will. A database table, however, is a different work or task or type. The structure of a database table must be explicitly defined before you can enter any data. A table structural definition includes items such as, of course, the name of the table. Each table within a database must have a unique name. The name of each field or column in the table, the data type of each field or the column, and the size of each field of the column. So, when it comes to the data type of each field, the data type determines what type of data the field can contain. Each field can contain only one type of data. If the field is designed to accept text data, only text can be added to the field. If you enter a number into a text field, that number is treated as text, which means that you cannot perform any calculation on such numbers. If you define a field to accept numeric data, you cannot enter text into that field. When we say the size of each field, the size determines the range of numeric or date values that can be entered, or determines the maximum number of characters that can be entered in a text field. So we need to take note that you may work with metadata before. Computer files have metadata associated with them in the form of the file properties, which you can use to locate a specific document or a particular image or a specific version of a program. If you have ever viewed a file's properties in Windows or added tags to an image on a social media site, you have worked with metadata. A primary key, no? A primary key is a field or combination of fields that uniquely identifies each record stored in a table. No two records in a table may be exact duplicates. However, two records may have identical data other than the primary key. The primary key, therefore, must be unique and it cannot contain a null value. In a database, null is equivalent to unknown and null is not the same thing as zero. Assigning a primary key prevents the entry of any record that contains duplicate or null values in the primary key field. When you add a record to a table for which a primary key has been assigned, the RDBMS checks to make sure you have included a table in the primary key field and that the value you enter does not already exist in the primary key field of any other records in the table. When you sketch a table schema, you can indicate the primary key by adding the notation PK to the right of the field name or by underlining the primary key field. Microsoft Access uses a key icon to the left of the field name to denote a primary key. And we need to take note that a primary key that is comprised of a combination of fields is called a composite key. So, the following figure show schema for two tables as what we have here. This one. The product table, no, the products table has a single field primary key, the item ID, this one. Okay? And the order items in this table, no, has a composite primary key, ordered ID field plus the line item field. Selecting primary key. Selecting a primary key can be a challenge. Many times, a simple numeric value that increments automatically. So, for example, an ID field is added to a table to serve as the primary key. However, sometimes a table already includes a field that it is natural choice for use a primary key. For example, in a table, that track books sales as ISBN field would be a good choice. So, a primary key must uniquely identify each record. A record primary key value can't be null. A primary key value must exist when the record is created. The primary key must remain stable and you can change the primary key fields. The primary key must be compact and contain the fewest possible attributes, and the primary key value can't be changed. A good choice for primary keys include people's name as they are likely to be duplicated and they sometimes change. And social security numbers, not everyone has one, and business do not like to store them because of the potential liability if they are lost or stolen. So, consider the table shown here, no? We notice that there are two entries for a person named Dennis Henderson as what we have here, no? If you look only at the first name or F name and L name, so this will be the F name and L name, fields, the record appear to be duplicates. However, if you look at this field in the address field, you can see the records are not duplicates. So if you see the address, no, they have different address. It would be possible to use the combination F name plus L name plus address as a composite primary key. So it would also be possible to use the zip field as the primary key because right now its entry for a zip code is unique. Neither of this is really a good solution. If we use the zip field as a primary key, we would be unable to add a record for another person living in the same zip code as any person already listed in the table. Using the combination of F name plus L name plus address field is not a good solution either because people move and the primary key for a person who relocates would change. A better solution for this table would be to add an ID field as shown in this figure here. We have an ID field here. Okay? When you use an ID field as a primary key, you can manually enter the ID number or you can elect to have the RDBMS create ID number automatically. In Microsoft Access, you can create ID number automatically by setting the ID field's data type property to auto number. A field with an auto number data type is automatically updated with a unique sequential number whenever a record is added to the table, and the value is an auto number field cannot be deleted or changed. The relationships foreign key. The data in the relational database is stored in multiple tables. So naturally, there needs to be a way to bring the data from those separate tables together in a meaningful way. And this is accomplished through the defining a table relationship. Table relationships are defined through the creation and association of foreign keys. A foreign key is a column or combination of columns in a table that references the primary key in another table. For example, consider the simple scenario of customers and orders. Suppose we have a customer table and an order table as what we discussed earlier. So, a one-to-many relationship exists naturally between customer and orders. One customer may place 0, 1, or many orders, but an order can be placed by only one customer. The ways the table are configured right now, there is no way to keep track of which customer places an order. We want to be able to trace an order back to the customer who placed it. The best way to keep track of which customer places an order is to create field that is common in both tables. In the order table, this common field will become a foreign key when we create a relationship between the tables. Here we see a revised design of the orders table. It not includes a field name, customer ID. This is the common field. It exists in both tables. In the customer table, the customer ID field is the primary key, denoted by PK in the diagram. In the order table, the customer ID field will become the foreign key. when a relationship is created between the two tables. The foreign key is denoted by FK in the diagram. So, once the common field is added to the orders table, you can create a relationship between the two tables. In Access, you can open a special window called the relationship window and drag the primary key field from that customer's table onto the common field in the orders table, and Access will create the relationship. Behind the scenes, SQL adds a constraint that will not allow you to add a record to the orders table if the value in the foreign key field does not match a value in the primary key field of a record in the customer table. It is as this point that the customer ID field in the orders table becomes a foreign key. That is, when you create a record for a new record, the value that you enter in the customer ID field in the orders table must reference a record that already exists in the customer table. You cannot create an order for a customer who does not exist. The following figure, okay, shows the data in the customers table in the orders table. In the customer table, the customer ID, no, as what we have here, no, customer ID field is the primary key. Okay? And it uniquely identifies each customer. However, in the orders table, the customer ID field is a foreign key. So, as what we have here. And it's used to refer to a specific customer in the customer table. We need to take note that the primary key to which a foreign key maps is also known as a parent key. The line draw between the two tables represent the relationship between the two tables. We need to take note that the line is drawn connecting the common fields. Open, the common fields have the same field name, but that is not a requirement. However, common fields must have the same data type. When you create relationship between tables, no, so as what we have here, no, this will be the line, customer ID, then connected to customer ID. When you create relationship between tables, you can view and work with data stored in multiple tables. For example, you can view customer and order information contained in two different tables to see which customer placed a particular order. The related tables shown in the figure indicate that in order 1, customer number 1012 or Helen Anderson placed an order on February 19. So yes, 1012 Helen Anderson placed an order on February 12 or February 19, sorry. Relationship types. There are three types of relationship that can be established between tables. So we have one-to-one. So a relationship in which each record in table A can have only one matching record in table B and vice versa. This type of relationship is not very common. So we have an example here. One-to-many. A relationship is in which a record in table A can have many matching records in table B, but a record in table B has only one matching record in table A. The relationship is established between the primary key in table A and the foreign key in table B. Many-to-many. A relationship in which one record in table A or table B can be related to many matching records in the other table. So for example, suppose a database contains data about students and classes. Each student can be enrolled in several classes and each class can have many students. This is a many-to-many relationship. Relational databases cannot directly handle many-to-many relationship, and this must be replaced by multiple one-to-many relationships. Database metadata, or what we call database schema. Earlier, we examined table metadata. However, there is also metadata for the entire database, the database schema. The database schema represents a logical view of the entire database. It defines how the data is organized and how the tables within the database are related to one another. You can represent relationship in database schema by drawing lines between the key fields in the related tables. The primary key of each table should be denoted either by an underlined field name or a representative icon. You represent the one side of a one-to-many relationship by drawing a 1 beside the parent key. And you represent the many side of a one-to-many relationship by drawing an infinity symbol beside the foreign key. So as what we have here. So the following figure shows a schema generated in Microsoft Access for a database with 4 tables. So this is infinity. So it means to say that many-to-many. The database schema is preceding figures describe the following relationship. There is a one-to-many relationship between the publisher's table and the books table based on the publisher ID field. There is one-to-many relationship between the books table and the author books table based on the book ID field. And there is a one-to-many relationship between the author's table and the author's book table based on the author ID field. As we noticed that the author books table is related to both the books table and the author's table. These two one-to-many relationships support to many relationship between books and authors. One author can write many books, and a book can have many authors. Database queries. You use queries to view specific data in one or more database tables. A query asks a questions of a table such as which customers live in Arizona and select records from the table which answer the questions. The selected records are displayed in a result set. A database query is a request for a data from a database, and usually the request is to retrieve data. However, data can also be manipulated using queries. The data can come from one or more tables or even other queries. Queries work by checking table fields for entries that meet the criteria that you specify. Criteria can be string or text, dates or number of range of number or range of numbers that you enter. The query examines each record in the table to determine if particular values in the record match the query criteria. If a record meets the criteria, then it is displayed in the result set. The result set of DynaSet or dynamic subset is not a static snapshot of records, but a dynamic changing subset of records. As changes are made to a table, the results of a query will change accordingly to reflect the current content of the table. So for example, suppose you run a query on a table containing 100 records, generating result with 30 records. If you then added another 20 records to the table and then run the query again, the results will also include any of the newly added records that meet the selection criteria specified in that query. If only 2 records of the additional 20 meet the criteria, then the query would generate 32 records, even though the same query generated only 30 records a few minutes ago. If you are working in a database, you can use a query to answer a simple question, view only specific table fields, perform calculations, combine data from different tables, or to add, change, or delete data or table data. Database forms. Forms are tools that aid data entry and help users understand what they need to do. They are user-friendly interfaces designed to help users enter specific data without becoming distracted or confused by other data that may be stored in a table. You can think of a form as a window into the data. Instead of allowing users to view all the fields in the table, a form displays just the data that is necessary for performing a given task. Consider the following figures. So as what we have here. The first row, a data entry from created in Access. A user can enter data about an order using the form. So as what we have here. Transparent to the user, the data entered through the form is added to the 4 database tables which are shown in the second figure. So as what we have here. Where are databases used? After this little worldwide tour, you may have already decided that you have had your fill of databases. They can be cumbersome and confusing, especially at first, and you may think you will never have a reason to use a database. However, chances are good that you interact with databases all the time and don't even know it. In short, databases are used almost everywhere you look. Medical records, flight reservations, legal pleadings, online orders, Pinterest, Twitter, Facebook, YouTube, and WordPress posts are all stored in a database. Because databases are used just about everywhere, including bank, retails, website, and warehouse. Banks use databases to keep track of customer accounts, balances, and deposits. Retail stores can use databases to store prices, customer information, sales information, and quantity on hand. Database and website. An online database is a database accessible from a local network or the internet, as opposed to one that is stored locally on an individual computer or its attached storage such as a CD, flash drive. Online databases are hosted on a website made available as software as a service products accessible via a web browser. The web is replete with databases because databases are extremely flexible and scalable. They can store millions and millions of records, and they can present data in almost any format you want or need. Online stores display thousands and thousands of items and allow you to sort and filter the items on the page by price, by vendor, by size, by color, and the options are almost endless. All the data that populates the page of choices is stored in a database. But you never have to see the database itself. Why? Because it is an easy thing for a web designer to design a web page that connects to the database on the back end, where the website visitor never sees it. Visitors simply enjoy a normal web experience while interacting with databases all the while. Static and dynamic website. Okay? There are two basic types of web pages. Static. These types of pages display content that does not change, no, unless the web page developer edits that what is on the page. There are the normal web pages you build with HTML or HTML. Anytime you visit a static web page, your computer sends a request to the server, and the server sends the web page to you over the internet. The page is stored on the web server and served in the same condition every time a request is received until the web developer edits it. Dynamic website or web page. These pages change every time they are loaded in the browser window. They change their content based on user actions. For example, if you are viewing digital cameras on the Best Buy website and you apply a filter because you want to see only GoPro cameras, the page is automatically rebuilt or regenerated and resent to you to your browser. Often, these pages are built using languages such as Active Server pages, Java Server pages, CGI, Python, or Perl. Database-driven web pages. One of the most common types of dynamic web page is the database-driven type. This means that you have a web page that grabs information from a database, or the web page is connected to the database by programming, and insert that information into the web page each time it is loaded. Many dynamic websites, as I mentioned, no, are database-driven. The web page is connected to a database through programming, and it pulls information from the database and inserts that information into the web page each time the page is loaded. As information is stored in the database changes, the web page connected to the database also changes to reflect the new data. Actually, it's automatically changes. Banking website use database-driven pages. You log in and view your account, and the web page connects to a database where all your account information is stored. The page always shows the most current information because it is connected to the data. So, before I end, this will be my references, of course. In this discussion, you learn basic database concept and learn how databases are used on the World Wide Web. You should now be able to describe the nature of the data, understand the purpose and functions of relational databases, describe databases elements, understand database relationships, understand how to read a database schema, and you are now able to describe the uses of database on the web. So, good luck. Enjoy the rest of the semester.